In the final years of the 20th century, the United States solidified its dominance in aerial combat. With groundbreaking aircraft like the Lockheed Martin F-22 Raptor and the Northrop Grumman B-2 Spirit stealth bomber, it looked like no other country could possibly catch up. These machines weren't just planes. They were seen as flying miracles of modern warfare. Back then, China was still working with outdated Soviet-inspired aircraft. But in the decades since, everything has changed. Now the skies over China feature increasingly familiar silhouettes, jets that closely resemble American fighters. And according to multiple intelligence sources, those similarities aren't just visual. Are we looking at a new global contender, or are these designs simply borrowed tech without the brain behind them? Let's begin with the most ambitious aviation effort in the United States today, the Next Generation Air Dominance Program, or NGD. Boeing recently secured a major contract under this initiative, surpassing even Lockheed and Northrop, to deliver a new sixth-generation fighter for the U.S. Air Force. Designated the F-47, this advanced aircraft has reportedly been flying in secret for nearly 5 years, aligning with a 2020 statement from the Air Force that NGAD had already entered test flights. But the F-47 isn't just another fighter jet. It's designed to be the centerpiece of a future aerial combat ecosystem, acting as the central brain of a network of systems, including autonomous drones and next-generation sensors. It's stealthier, smarter, and faster than anything before it. Cost-wise, it's set to be cheaper than the F-22, which means the U.S. Air Force plans to acquire up to 300 of them, replacing its current fleet of around 180 Raptors. The design is tailless for better radar evasion and features next-gen canards to enhance agility. It'll boast adaptive propulsion engines generating up to 40,000 pounds of thrust, pushing the aircraft beyond Mach 2. Its range, over 1,500 miles. The F-47 will come in both piloted and unmanned versions, with mission-specific configurations. And its weapons package? Hypersonic missiles, swarming drones, and soon, laser weaponry. This is no longer science fiction. Lockheed Martin is already working to integrate directed energy weapons into U.S. fighters. Meanwhile, China's answer to America's sixth-gen efforts is wrapped in secrecy. But glimpses have emerged. In late December, video footage surfaced showing 2 new aircraft flying over Chengdu in Sichuan province. One believed to be the heavy J-36, the other a lighter model suspected to be the J-50. Both designs resemble a tailless flying wing, like the U.S. concept. One of the aircraft bore the number 36, fueling speculation about its designation. Analysts believe Chengdu is behind the J-36, while Shenyang is responsible for the J-50. But whether they belong to a single development program or 2 parallel ones remains unclear. Sources claim the J-36 might be powered by China's WS-15 engine or an undisclosed next-gen system. Its range is expected to be about 1,200 miles, a bit short of the American F-47. However, the key difference may lie in systems integration. While the U.S. builds its aircraft to operate as part of a massive, interconnected command and control web, China's doctrine still prioritizes local tactical integration rather than global reach. So even though the J-36 might match U.S. fighters in speed or stealth, it lacks the deep digital backbone that makes American systems so effective. Let's not forget the 5th-generation F-35 Lightning II, a plane that changed the game. Over 1,000 units had been built by 2022. Known for its versatility and rapid response capability, the F-35 is now in service across a wide network of U.S. allies. What makes it so powerful? Its stealth features, advanced avionics, and unparalleled sensor fusion offer a tactical awareness that no other aircraft currently matches. But developing it wasn't easy. Its mission system software alone contained over 8.6 million lines of code in the 3F block, and the more advanced Block 4 update required major improvements to cooling systems and hardware architecture. In the future, the F-35 will integrate more closely with NGAD platforms and drone teammates. Lockheed is working on giving the F-35 up to 80% of the capabilities of the future F-47, but at only half the cost. Meanwhile, China has its own multi-role stealth fighter, the J-35, also referred to as the J-31 or FC-31. This jet aims to rival the F-35 in both air-to-air and ground strike capabilities. Its radar system and helmet display are inspired by American and British tech. In September 2023, the Chinese military revealed the first flight of the land-based J-35A, an offshoot of the carrier-based version, with modified wings and landing gear. Despite its progress, the J-35's tech still lags. It lacks the full sensor integration seen in the F-35 and remains dependent on more conventional radar systems. And there's more controversy. In 2013, U.S. defense officials alleged that Chinese cyber attacks on the F-35 program allowed them to accelerate their own development. The similarities between the F-35 and J-35 are hard to miss. Comparable size, layout, and overall function. But when it comes to actual combat readiness, the J-35 is still in the testing phase, while the F-35 has proven itself in missions over Iraq, Syria, and Afghanistan. Speaking of experience, the F-22 Raptor, America's first fifth-generation stealth fighter, remains unmatched. Its export was banned by law to protect sensitive tech. Every inch of the Raptor was sculpted for stealth. Seamless surfaces, angled edges, and super maneuverable engines. The twin Pratt & Whitney engines produce over 35,000 pounds of thrust each, enabling the F-22 to cruise at supersonic speeds without afterburners. So is China catching up? Absolutely. But are they there yet? Not quite. While Beijing pushes forward with ambitious stealth programs, the United States continues to evolve its aerial arsenal with advanced networks, autonomous systems, and a level of battlefield intelligence China hasn't yet matched. The race for air dominance is far from over, and what happens next might just redefine the future of warfare in the sky. If you found this deep dive into the future of aerial combat fascinating, be sure to like, subscribe, and hit that bell icon so you don't miss our next episode on the evolving balance of global military power. Thanks for watching. Imagine traveling from New York to London in just over 3 hours, cutting transcontinental travel time in half. It's a dream that's closer to becoming a reality than ever before. But can we overcome the challenges of supersonic travel to make it practical, affordable, and safe? Let's dive into the cutting-edge technology shaping the future of aviation. For decades, the idea of ultra-fast aircraft capable of crossing continents in mere hours has captured the imagination of engineers and travelers alike. While aviation giants like Boeing and Lockheed Martin are advancing hypersonic missile technology, a groundbreaking company named Boom Supersonic is tackling a different challenge, bringing back supersonic passenger flights. With their XB-1 demonstrator and ambitious Overture airliner in development, the dream of supersonic travel might soon become a reality. But is this vision practical, and are we truly ready for such rapid advancements? Let's find out. The concept of hypersonic and supersonic flight has a long and turbulent history. Aerospace historian Richard P. Hallion once compared faith in hypersonics to belief in the second coming. Everyone knows it's possible, but no one is sure when it will happen. For over 60 years, hypersonic technology has seen cycles of interest and stagnation. Early challenges with rocket engines, re-entry protection, and air-breathing engine designs deterred progress. The Cold War-era military focused on traditional fighters and bombers, sidelining hypersonics due to their steep technological barriers. Today, however, hypersonics and supersonics are resurging, fueled by advancements in materials, engine technology, and the geopolitical arms race. Hypersonic weapons are viewed as game changers by the Pentagon, while companies like Boom Supersonic are looking beyond military applications to revolutionize commercial air travel. Boom Supersonic's XB-1, affectionately nicknamed Baby Boom, is a scaled prototype paving the way for the Overture, a supersonic passenger jet designed to carry 65 to 80 passengers at Mach 1.7. That's twice the speed of today's fastest commercial airliners. The XB-1's innovative design includes advanced composite materials, titanium, and stainless steel capable of withstanding extreme temperatures. Its sleek, swept-wing structure minimizes drag and maximizes efficiency, while its 3 General Electric J85-15 engines provide the power needed to break the sound barrier. But the real game changer lies in Overture's promise to solve the long-standing issue of sonic booms. By flying supersonic routes primarily over oceans and subsonic over land, Boom's team aims to eliminate disruptive noise pollution. The Overture also leverages sustainable aviation fuel, SAF, striving for net zero carbon emissions, a nod to the increasing demand for eco-friendly travel. Despite setbacks, including pandemic-related delays, Boom has made remarkable progress. In 2023, the XB-1 completed its ground testing in subsonic flights, demonstrating its stability and efficiency. The company now aims for its first supersonic test flights in 2024 and plans to have the Overture ready for commercial service by 2029. The path to revolutionizing air travel with supersonic speeds is not without its hurdles, and one of the most significant challenges is cost. The Overture, Boom Technologies' ambitious supersonic airliner, comes with an estimated price tag of $200 to $250 million per jet. This high production cost will inevitably influence ticket pricing, especially in the early stages of commercial operations. The parallels to the iconic Concorde, which charged passengers around $10,000 for a transatlantic ticket in the 1990s, roughly $20,000 when adjusted for inflation, are hard to ignore. These steep prices made the Concorde a luxury experience, accessible only to an elite few, and the fear is that Overture might face the same initial exclusivity. However, Boom Technology has a bold vision that extends far beyond catering to the wealthy. The company's ultimate goal is to make supersonic travel accessible to the masses. Blake Scholl, Boom's CEO, dreams of a future where traveling across the globe at supersonic speeds isn't a privilege reserved for the few, but a reality for many. The dream includes ticket prices dropping to as low as $100 for a 4-hour global journey, a proposition that sounds like science fiction today. Achieving this goal will require breakthroughs in not only technology, but also manufacturing efficiency, operational scalability, and partnerships with airlines willing to invest in a new era of air travel. The race for supersonic travel is heating up, and Boom Supersonic is at the forefront of this groundbreaking movement. With their innovative designs and ambitious goals, they might just redefine the way we travel. But will supersonic flights ever become as commonplace as modern subsonic airliners? Or will the challenges of cost, noise, and infrastructure keep this technology out of reach for most travelers? Let us know your thoughts in the comments below. If you enjoyed this journey into the future of aviation, don't forget to like this video, subscribe to the channel, and hit the notification bell for more insights into cutting-edge technology. Thanks for watching, and we'll see you in the next video. At the dawn of the 21st century, an experimental aircraft emerged from the shadows, one that could have redefined the battlefield forever. Known as the X-44 Manta, this tailless flying marvel promised unmatched stealth, agility, and range. But in a shocking turn, the project vanished almost as quickly as it appeared. Or did it? Some say the X-44 didn't die. It evolved, hidden beneath the skin of today's next-generation air dominance fighters. Could a forgotten prototype be the foundation of tomorrow's air superiority? Lockheed Martin, the name behind the stealthy F-117 Nighthawk, the powerful F-35 Lightning II, and the legendary SR-71 Blackbird, has a long history of creating revolutionary aircraft. But not every innovation sees the light of day. One of the boldest yet most secretive was the X-44 Manta, a concept that pushed the limits of what an aircraft could be. Part of the U.S. military's X-plane initiative, the X-44 wasn't just a new jet, it was a new philosophy in flight. Inspired by the Manta Ray, this aircraft ditched traditional control surfaces. No tail, no rudder, no vertical stabilizers. Instead, it relied entirely on vectored thrust, using adjustable engine nozzles to steer. It was sleek, stealthy, and engineered to be highly agile while minimizing radar exposure. Built on the F-22 Raptor's foundation, the MANTA incorporated its engines and fuselage, but with radical differences. A massive delta-wing design gave it more fuel capacity, greater range, and the ability to carry heavier payloads internally, preserving its low radar signature. Armaments included everything from short-range Sidewinder missiles to 1,000-pound precision-guided bombs, all stored within the aircraft to maintain stealth. Powered by two mighty Pratt & Whitney F119 engines, with afterburners generating 35,000 pounds of thrust each, the Manta could potentially reach Mach 2 speeds and soar up to 49,000 feet. Yet despite this potential, the program was quietly shelved around the year 2000. Officially, the Pentagon shifted its focus to the more versatile F-35 and continued F-22 production. But insiders suggest something else. NASA took interest in the X-44's innovations, particularly its tailless configuration and vectored thrust, and repurposed the concept for research. Behind closed doors, some believe the Manta's DNA was integrated into future fighter programs, most notably the Next Generation Air Dominance (NGAD) initiative. The NGAD program is America's vision for sixth-generation air combat, and it shares striking similarities with the X-44. A tailless design, advanced stealth, potential for unmanned operation? Absolutely. While the Manta was originally intended as a manned aircraft, its design is a natural fit for today's autonomous drone technology, especially in high-risk missions. However, there's a new battlefield threat: infrared search and track systems, IRST. These sensors can passively detect heat signatures, making even stealth jets vulnerable. Unlike radar, IRST can't be jammed or spoofed. Lockheed Martin and the Air Force are likely developing countermeasures, like temperature regulation and stealth-enhancing coatings, to reduce the thermal footprint of next-gen aircraft. And environmental factors, fog, rain, haze, can also limit IRST effectiveness, giving stealth aircraft an edge. The NGAD is being designed to operate in any weather, in any region. With two configurations planned, one for European theaters, the other for longer-range Indo-Pacific missions, flexibility is key. The X-44 Manta may not have had the long-range endurance needed for escort missions over vast oceans, especially in a conflict with China. But its core concepts, agility, stealth, thrust vectoring, and internal payloads, were ahead of their time. Today, the Air Force isn't just building a new fighter jet. They're engineering an entire family of interconnected systems designed to redefine the very nature of aerial warfare. This next-generation approach goes far beyond the traditional image of a lone pilot in a high-performance aircraft. Instead, it envisions a powerful ecosystem of manned and unmanned platforms operating together with seamless coordination, speed, and precision. At the heart of this evolution is a bold concept: human pilots working side by side with artificial intelligence, each complementing the other's strengths, all connected through an advanced digital nervous system in the sky. These AI-powered drones, known as Collaborative Combat Aircraft (CCAs), aren't just remote-controlled tools. They're designed to think, react, and even anticipate threats on their own. They can scout enemy positions, jam radar systems, deliver precision strikes, or shield their manned counterparts from incoming fire. Think of them as loyal wingmen, flying autonomously or semi-autonomously alongside piloted jets, guided by algorithms trained on countless hours of real-world and simulated combat data. Their presence allows the human pilot to make faster, more informed decisions under pressure, transforming the fighter cockpit from a solitary command post into a node within a high-speed AI-enhanced swarm. But this vision isn't just about drones and jets. It's about networks, massive, secure, and lightning-fast information pipelines that connect every aircraft, satellite, radar station, and command center in real time. The future battlefield will be saturated with data, and whoever processes that data faster and more accurately will dominate the skies. The U.S. Air Force is investing heavily in these networking capabilities, creating systems where information flows freely across domains: air, space, cyber, and land. This ensures that every asset, manned or unmanned, always has the latest intelligence, target information, and threat assessments, leading to coordinated attacks and efficient defense. What makes this approach revolutionary is that it shifts the focus away from developing a single superjet with all the bells and whistles. Instead, it embraces a distributed, flexible, and resilient model of air power, one that values teamwork over individual performance. A pilot no longer has to do it all. The load is shared across a diverse team: human brains for intuition and judgment, AI for speed and complexity, drones for reach and expendability, and networks for instant communication. This transformation is reshaping the very fabric of military aviation. It's not just about building better planes. It's about building a smarter, more adaptive, and more lethal war-not combat ecosystem. The skies of tomorrow won't be ruled by the best aircraft alone, but by the best collaboration between man, machine, and data. In this new era, victory will come not from solo acts of heroism, but from synchronized, intelligent teamwork. So was the X-44 Manta a ghost of aviation history, or the secret blueprint for America's most advanced fighter yet? One thing's clear: in the silent arms race for air dominance, legends never truly die. They just evolve. If you found this deep dive into black projects and future fighters fascinating, smash that like button, subscribe for more untold stories of aviation and defense tech, and let us know in the comments. Do you think the X-44 still flies somewhere in the shadows? Finally, U.S. Air Force declared SR-72. Dark Star is real. They said it was science fiction, a myth, a fantasy cooked up by aerospace dreamers. But what if we told you the next era of American aviation is already here, only cloaked in secrecy? For years, whispers about a mysterious aircraft known only as the SR-72 have circulated through defense circles and aerospace communities. Many dismissed it as a concept that would never leave the drawing board. But then, the puzzle pieces started to fall into place. Hidden behind the ultra-secretive walls of Lockheed Martin's Skunk Works, it seems something revolutionary is unfolding. Is the United States quietly crafting the fastest aircraft in human history? Let's dive deep into the classified shadows and see what lies beyond. Before we jump into what's coming, let's rewind to a legend. The SR-71 Blackbird. Born in the Cold War's crucible, this jet looked like something from a sci-fi film. A sleek, dark body tapering into a dagger-like nose. Its wings housing twin-engine nacelles, capable of roaring to Mach 3.2. It soared to 85,000 feet, so high pilots had to wear pressurized spacesuits just to stay conscious. Built with an eye on stealth, the Blackbird's radar cross-section was minimized long before stealth became mainstream. Its matte black skin wasn't just for looks. It was coated in radar-absorbing, iron-based paint that managed heat and deflected enemy sensors. A full 85% of its structure was titanium, and much of it used specially formulated alloys designed to withstand extreme heat. The outer skin wasn't even smooth. It was corrugated, a feature that helped prevent cracking or warping under thermal expansion at high speeds. Even the windshield was next-gen, with triple-layered quartz glass ultrasonically sealed to a titanium frame. The Blackbird was a ghost in the sky. Over 4,000 missiles were fired at it throughout its service. None of them ever made contact. But as technology advanced, the costs of maintaining such a marvel became unsustainable. In 1998, the SR-71 was finally grounded. NASA gave it one final hurrah before it, too, bowed out in 1999. But legends never die. They evolve. As early as the 2000s, Lockheed engineers knew it was time to build the next step, a true successor. By 2006, Skunk Works teamed up with Aerojet Rocketdyne to develop a revolutionary propulsion system, a turbine-based combined cycle engine, TBCC. This cutting-edge hybrid could handle subsonic, supersonic, and hypersonic flight, using turbine jets to get airborne and scramjets, supersonic combustion ramjets, to push into Mach 6 territory. But flying at 6 times the speed of sound isn't just about engine power. It's about heat. At those speeds, traditional materials would melt, so engineers had to push the envelope again, turning to exotic carbon ceramics and metal composites, the same stuff used on ICBMs and space shuttles. In 2013, Lockheed Martin finally went public. The SR-72 was real, and it would be twice as fast as the Blackbird. A new motto emerged: speed is the new stealth. Unlike its predecessor, which was built with slide rules and no onboard computers, the SR-72 would be born from digital models, AI-driven simulations, and additive manufacturing. By 2016, Lockheed's CEO said they were on the verge of a breakthrough, promising a full-sized hypersonic prototype for under $1 billion. And in 2018, those claims were reaffirmed. The digital tools had caught up to the vision, making the son of Blackbird possible not just in theory, but in steel, ceramic, and fire. The SR-72's primary payload? Hypersonic weapons. The U.S. military is already working on these next-gen missiles, and Lockheed proved decades ago that it could launch missiles at Mach 3 using its YF-12 prototypes. Doing so at Mach 6 is the next logical leap. Still think this is all fantasy? Remember the secretive hypersonic jet featured in Top Gun, Maverick, Dark Star? It wasn't just Hollywood magic. Skunk Works helped design it, and it looked so real that, according to reports, China redirected a spy satellite just to get a glimpse of it. Whether it was fiction or not, the line between movie magic and military technology is becoming increasingly blurry. Initially, test flights for the SR-72 were rumored to begin in 2025. Now, estimates push those expectations to sometime between 2027 and 2029. What's more certain is that it aligns with the U.S. Air Force's long-term hypersonic strategy. Funding is in place, the momentum is real, and the race to stay ahead of Russia and China is on. Of course, the cost of developing the SR-72 will be nothing short of astronomical. We're talking about a program that could rival the budgets of entire defense departments, an endeavor that demands not just funding, but political will, secrecy, and the most advanced engineering talent on the planet. And don't even think about seeing an export version. This isn't just another fighter jet or reconnaissance plane. This is a flying vault of top-secret technology. The SR-72 will house some of the most classified, cutting-edge systems ever authorized by the Pentagon. Technology so sensitive, its existence alone could shift the global balance of power. Hypersonic propulsion, stealth capabilities beyond our current understanding, AI-assisted navigation and targeting systems. These aren't features for sale. Not now, not ever. But when this mysterious aircraft finally breaks through the veil of secrecy and streaks across the sky, it won't just be another marvel of aerospace engineering. No, it could mark a turning point, a moment where the limits of modern aviation are redrawn, a glimpse into the future of warfare, surveillance, and flight itself. When it finally emerges from the shadows, the world may never look at the skies the same way again. So, when will the skies tremble once more at the roar of a new blackbird? And will the SR-72 truly live up to its mythic expectations? Let us know what you think in the comments below. Will it stay locked behind hangar doors, or will it blaze a new trail across the sky? What if I told you the US just tested a top-secret hypersonic weapon so fast and advanced, it could leave even the legendary SR-72 Dark Star in its dust? In a world where speed is power, a silent revolution has just taken place high above our heads. The United States has reportedly conducted a covert hypersonic weapons test that has left defense analysts, scientists, and rival nations in total disbelief. Whispers from deep within the aerospace community suggest this next-gen technology might have shattered Mach 6 and possibly even touched Mach 10. And that's right, an aircraft potentially faster than the SR-72, the supposed successor to the iconic SR-71 Blackbird. But what exactly did they test? And how did it leap beyond the known limits of speed and science? Buckle up, because we're about to journey into the extraordinary world of futuristic flight that's rewriting the rules of aerospace warfare. At first glance, hypersonic technology seems like it belongs in a sci-fi epic. But this isn't fiction. It's the culmination of decades of scientific grind, secret experiments, and innovation, stretching all the way back to the Cold War era. While we tend to think of hypersonics as a 21st century marvel, its roots trace back to the high-stakes US-Soviet arms race, where both sides competed fiercely for dominance in the skies and beyond. Back in 1959, the X-15 rocket plane blazed through the sky and into the history books, reaching Mach 6.7, still a record for manned flight, but it came at a cost. The X-15 relied on rocket engines that guzzled fuel and had minimal flight time, making long-distance travel utterly impractical. The idea of practical hypersonic flight sat dormant for decades, collecting dust in black-budget research labs, until now. Today, with global tensions rising and nations scrambling for technological supremacy, hypersonic research has roared back to life. The dream? Create ultra-fast, maneuverable systems that can dodge missile defenses and strike targets with razor-sharp precision. Enter the age of air-breathing engines. Unlike rockets that carry bulky oxidizers, scramjets and ramjets inhale atmospheric oxygen, massively improving fuel efficiency. Rocket engines max out around 450 seconds of specific impulse, while air-breathing tech like scramjets can exceed 1,000 seconds, enabling longer, faster, and more practical missions. Here's the catch. Scramjets don't work at low speeds. That's why engineers often use hybrid propulsion systems, combining turbojets for takeoff and ramjets for sustained hypersonic cruise. And one startup, Hermes, is changing the game with this approach. Meet the Chimera engine, a turbine-based combined cycle propulsion system inspired by the mythical creature. It seamlessly shifts between turbojet and ramjet modes, allowing their aircraft, the quarter horse, to take off like a traditional jet and then accelerate into hypersonic territory, all without the need for a separate launch vehicle. Hermes didn't just dream this up, they built it. In just 21 months, with a shockingly small budget of $18 million, they outpaced billion-dollar defense programs. Their engine uses the battle-tested General Electric J-85 turbojet, used in aircraft like the T-38 Talon, and they're already advancing to Chimera 2, now powered by the mighty Pratt & Whitney F-100, the same engine behind the F-15 Eagle and F-16 Fighting Falcon. But speed comes with heat, and lots of it. Hypersonic travel generates skin-melting friction temperatures. Hermes tackled this with innovative thermal design and a breakthrough pre-cooler that chills incoming air before it hits the engine. This not only boosts performance, but protects the system from overheating, an essential step toward reusable hypersonic flight. Now, Hermes is setting its sights higher, literally. Their next-gen aircraft is being designed to cruise at altitudes between 80,000 and 85,000 feet, double the cruising height of commercial jets, and possibly even break the SR-71's top speed of Mach 3.3. That means soaring through the thin upper atmosphere at blistering speeds, pushing the limits of what we thought was possible. This aircraft isn't just a technological leap, it represents a seismic shift in how humanity thinks about speed, power, and strategic dominance. What we're witnessing isn't merely a faster plane. This is a machine capable of outperforming even the most advanced missiles, evading detection systems designed to track threats in real time, and reaching virtually any target on Earth within mere minutes. We're entering a new era where national borders, geographic obstacles, and even oceans become irrelevant in the face of such speed and precision. Imagine this: traditional intercontinental ballistic missiles, despite being extraordinarily fast, still follow a predictable arc and trigger immediate alarms when launched. They can be intercepted, tracked, and potentially neutralized by missile defense systems. This isn't just about military superiority, although that's clearly one of its major implications. The existence of such an aircraft redefines what response time means in modern warfare. Strategic deterrence has always depended on the ability to respond swiftly and decisively to threats. But now, with a platform that could strike anywhere in the world in under an hour, potentially within just 20 minutes, those old metrics become obsolete. Leaders and defense strategists will be forced to reconsider everything from troop deployment and border security to nuclear deterrence and global conflict escalation protocols. But the impact doesn't stop at the battlefield. This aircraft also hints at the future of global transportation. A flight from New York to Tokyo currently takes around 14 hours. With hypersonic technology, that same journey could be reduced to under 2 hours. Business, diplomacy, tourism, and humanitarian aid could operate on timelines that were previously unimaginable.